This is my voiceover in completing the proof in number 7 on the review packet for sections 3-3 to 3-5. So the first thing I'll do is I will mark my given information into the diagram. So I'm given that line M is parallel to line N, so I'll mark those with single arrows. And I'm told that line R and line S are parallel, so I will use double arrows to show that. I'm also told that the measure of angle 1 is 130 degrees, so I'm going to write that in the space that angle 1 occupies. I need to prove that the measure of angle 3 is 50 degrees. So the first statement is always my given information. So I'll just copy that in here. And its reason is that it's given. So now I need to use the second reason as a clue to figure out what the second statement should be. The second reason says that corresponding angles are congruent. So I'm going to look at my diagram to see if I can find some corresponding angles. And in the diagram, the only angles that are labeled with numbers here that are corresponding are angle 1 and angle 2. So that must mean that we are saying that angle 1 is congruent to angle 2. So then in step 3, we can conclude that angle 2 has the same measure as angle 1, which is 130 degrees, because congruent angles have equal measures. In step 4, angle 2 plus angle 3 measures 180 degrees. So if I look back at the diagram, angle 2 and angle 3 are consecutive interior angles. So the reason for that is those parallel lines cut by a transversal are forming consecutive interior angles that are supplementary. So now it looks like in step 5, the measure of angle 2 has been replaced by 130 degrees. If we have a replacement, that's describing substitution. And then I know my last statement has to be what I'm trying to prove. So that's the measure of angle 3 equals 50 degrees. And if I look back at line 5, it looks like the 130 was subtracted from both sides of the equation. So that is the subtraction property of equality.